Okay, thanks, Marco. Thanks very much. So yeah, as Marco said, my name's Dave Godlove. I'm currently the product manager at Sylabs Inc. Um, my background is actually biological sciences, so this is a good meeting for me to be a part of and to attend. I used to be at the National Institutes of Health as a neuroscientist. I worked there as a researcher for a couple of years. I became interested in high performance computing while there, and I joined the BioWolf team, which is the high performance computing resource at the NIH. While there, users began to talk about needing containers. I started to look around for any solutions that could work in HPC. I met Greg. He was in the process of, starting to program Singularity. And so it was a natural fit. And when Greg started to hire people to actually develop Singularity full time, it was a natural transition for me to join him and join this group. So that's a little bit of my background. And today I'm going to be talking to you a little bit about Singularity. Since this meeting is focused on Linux containers, I'm going to assume that most people are pretty much aware of what Linux containers are. And so I'm really just going to kind of focus on Singularity and its place within the Linux container ecosystem. So first, let me give you just a kind of a brief history. So I already mentioned Greg's name. Greg Kurtzer invented Singularity while working at Lawrence Berkeley National Labs. He was an HPC architect. He had been there for about 20 years. And he had the same experience that many of us in HPC were having around that point in time, around 2015, where users were coming to him and asking to install Docker on the system. And so he did what many of us did, and he went and he started to investigate Docker, and he realized that for a variety of different reasons, it's not a great fit for most HPC environments. But then he went a step further than what most of us did, and he actually said, let me begin to create a solution which actually will provide containerization in HPC environments. So he went to users and he began to get requirements from users, and he began development in October of 2015. He created the first release of Singularity 1.0 in April of 2016, and he went back to the users with that release, and basically it was kind of a flop. So users looked at it and they said, well, that's not really what we're looking for. He got a lot of feedback, and he actually started to grow the community. This is one of the great things that he did with Singularity is he went to the community and got help. And the community began to contribute and develop Singularity as well. This led very quickly to the release of 2.0. And then Greg actually was able to, he had the good fortune to be able to actually hire some developers to work on Singularity full time. So myself, Michael Bauer, Yannick Cote, we all came and we began to develop Singularity full time. We worked on the 2.4 release that came out in October of 2017. Greg eventually founded a startup called Sylabs, so Sylabs Inc, and that's the company that I work for now. And working with Greg, we started off January 2018. We had there were 4 of us, 4 founding members. There are now something like 34, so we're growing at an extremely rapid pace. And in October of last year, Sylabs completed its first major task, which was a complete overhaul of the code base and the release of Singularity 3.0. So I'm going to be talking a little bit about 3.0 today and some of the new features and some of the changes there. So, being as this is a conference which is focused on high performance computing, I think most of the people who are in attendance here have probably heard of Singularity or probably aware of it if you're not using it already. Just to give you an idea of some of the other centers which are using Singularity and some of the company that you're probably in if you're using it. The fastest supercomputer currently on the top 500, Summit at Oak Ridge, is using Singularity. Also, have highlighted down here, Astra, which is currently the fastest ARM supercomputer, is using Singularity. And then I'm not going to go through all these, but you can see there's lots of names that you're probably familiar with. Lots of big centers in HPC are obviously using Singularity, and it's obviously working pretty well for them. So what distinguishes, so I said I was going to focus a little bit on Singularity and its place in the Linux container ecosystem. So what distinguishes Singularity from other container platforms? Well, first is the security context. So this was really the main reason why most of us in HPC around 2015, 2016 wouldn't install Docker when our users came and asked us for it, because we started to do some research and we found that the security context, while fine for microservice cloud native architecture, which is what Docker is good at, it doesn't really fit with the HPC model very well. So in a nutshell, what Singularity allows you to do is, as an administrator, you probably have lots of untrusted users on your system, i.e. users that don't have root access. And you probably don't want to vet every single thing that they run. So Singularity allows you to have untrusted users running untrusted containers on your system, and doing so in a secure way that's, that you can be sure that they're not going to be able to damage your system. Another thing that's different about Singularity is it's got a unique image format. So pretty much almost all, I'm going to say kind of traditional container platforms use a layered image format. This is the OCI image format. Singularity is a little bit different in that it takes a container and it packages it in a single file. Most recently, with the advent of Singularity 3.0, that file is known as a SIF, or a Singularity Image Format file. And this allows maximum portability, reproducibility, and trust. And I'm going to be talking about that a little bit later. So portability comes about because if you can copy files from one location to another, you can copy your container from one location to another. It's really that simple. You don't have to set up any kind of a registry or export your container as some kind of a bundle or something like that. You can just copy it. If you want to make sure that it's reproducible, you could create a checksum of that container, and look at the copy that you made and make sure the checksum is equal. So you can ensure that it's a bit for bit reproduction of the original container, which is a little bit hard to do with a collection of tarballs, because when you splat them out to disk, there's a lot of things to consider, when you're doing that. The philosophy of Singularity is a little different from other container runtimes as well. So most container platforms, they start off, they're kind of trying to replicate what a virtual machine does. And so because of that, you tend to start with the highest level of isolation possible. And then as a user, if you want to do things like read files from the host system, or write files to the host system, or leverage custom hardware like GPUs or high-speed interconnects or things like that, or just something simple like leveraging the network on the host system, you have to start poking holes in the isolation that already exists. You have to start tearing down levels of isolation. Singularity kind of starts from the opposite end of the spectrum, and it says users are likely going to want to do things like read and write data to the system and leverage GPUs and things like that. So it starts off actually with a very low level of isolation. The only thing which is the only namespace, Linux namespace, which is entered by default is the mount namespace. And then if you want additional layers of isolation, you can actually build those up. So it comes at containers from a different philosophy, from a different idea that most traditional container platforms do. And that's part of a larger philosophy that Singularity has, that it should be a batteries included, fully featured solution. So it does things like integrate with MPI in a way that's very easy to use. It does things like make GPUs transparent and easy to use for the user. It integrates seamlessly with batch schedulers, and it also allows you to launch jobs at really large scales very easily. Okay, so that's, in a very quick whirlwind tour, what's different about Singularity from other container platforms. I want to talk a little bit, if you're already using Singularity or you're familiar with it, I want to talk a little bit about the 3.0 version of Singularity and what's new there. So the biggest thing that was introduced by Sylabs with the 3.0 release of Singularity is what we're calling the Singularity Container Services. This includes the container library, the remote builder, and the key store. So what this is, so that the remote builder gives you a place to be able to build a container using our infrastructure, and you can do so from the command line, or you can do so through a web GUI. So for instance, if you wanted to build a container, instead of just building it on your local resource, you could type Singularity build -- remote, and then the name of the container you want to build and the definition file. And the advantage of doing that is when you do that, you don't need root access. So it's no longer necessary to have root access to build a container. That's the remote builder. There's also a container library. This is a place to store your containers, distribute them to your colleagues, find containers which have been created by others, download those, and so on. And then finally, there's a key store. And I mentioned a little bit earlier about trusting containers in the Singularity image format. So the Singularity image format actually has multiple different partitions of data. And one of those partitions is a signing block. And what this allows you to do, and all this is integrated into the 3.0 CLI, what this allows you to do is it allows you to create a PGP key, sign your container with that key, and then you can push your public key to our key store, and then anybody who downloads that container can then verify that you were the author of the container. This allows companies now to push containers up that they verify and vouch for, and when you download those containers, you can use the verify command and pull that public PGP key material and use it to verify this container has been signed, and it's a bit-for-bit reproduction of the original container that was created by the company. So this is altogether, these three services that make up the Sylabs container services provide an end-to-end solution for creating and then distributing trusted containers. CIF is now the default container format. So as I just said, this allows you to sign and verify your containers. It's also a very extensible format, which is going to allow us to put many more features into Singularity in the future. We now, in Singularity 3.0, have full network virtualization capabilities provided by CNI. This is the same group of plugins which Kubernetes uses to provide network virtualization. So this is a very full-featured and complete solution. As an administrator, you now have fine-grained control over the security context of containers in 3.0. You can do things like add and remove Linux capabilities. And you can also use kernel security modules like SE Linux, AppArmor, and SecComp directly into the container if those are installed on your host system. 3.0 introduces native support for C groups. So, previously we were relying on the fact that most Singularity containers would be scheduled through a batch scheduling system. And we were relying on the batch scheduler to make sure that to set up C groups and make sure that a container runs within its resources. You can do that now without a batch scheduling system if you like. And Singularity 3.0 also integrates more with Docker and OCI containers, making it easier to run those types of containers. So that was the 3.0 major release. Since then, it's getting to be about a month and a half ago, we've actually done another release, so 3.1. And 3.1, the major new feature that it adds is OCI compliance. So you've probably, if you haven't talked a little bit about OCI, you probably will during this meeting. So OCI is the Open Container Initiative, and it's a series of standards allowing tools like Kubernetes, for instance, to work with pretty much any container runtime. So now, version 3.1 of Singularity introduces an OCI command group, which allows you to have a fully OCI compliant container runtime. and also allows you to do things like mount a CIF file and expose it to the host system as an OCI bundle. Concurrent with this effort, excuse me, we've also been working on another project, Singularity CRI. So this is a CRI shim for Kubernetes, and this was released in alpha a few weeks ago. And so basically with these two things together, now it's possible, and people are doing this every day at this point, to orchestrate your Singularity containers through Kubernetes. So this is really, you know, a big step for Singularity. Okay, I want to talk to you a little bit about the future work that we've got in our roadmap, what we plan to develop in the immediate future. So one of the things that we're currently working on is a plugin framework. And this is going to allow third parties to create tools that work directly with Singularity. So for instance, if you're using Singularity now, you might be familiar with the --NV option. So that's an option that you can pass at runtime to expose the GPU to the container internally. We've been, you know, writing that and maintaining that for some time now, but with this new plugin system, it's going to be possible for someone like NVIDIA to come along and write a plugin and start maintaining the --NV option on their own. Or for other companies like AMD, for instance, if they, you know, want a similar plugin for their GPUs. Or maybe we've been talking about providing the same types of things for high-speed interconnects so that you can mount those into the container at runtime as well. There's a lot of different options here. We're also going to introduce multi-stage builds. This is something that a lot of users have been asking for. The basic idea here is that when you create a container, maybe you've got to compile, let's say, some Go binary. So in order to do that, you have to install Go inside the container, obviously. You have to have a compiler. You have to have kind of a big, heavy container. Well, at the end of that, when you actually run the container, you probably don't want all that development environment inside the container. So with multi-stage builds, you can build one container, which is the development container, and then within the same definition file, you can copy things like compiled binaries from the original container into the new container, and then you end up with just a slim container that only has exactly what you need in order to run. We're also developing encrypted containers for you know, people who have really important security-related applications. So perhaps maybe you've got data which is protected under privacy laws. And so because of that, you have to be careful about how you analyze your data on a shared resource. Encrypted containers are going to be encrypted at rest, in transit, and actually even when they run. So they're going to be mounted to the loop device in an encrypted way. We're also working on transparent Windows support. So if you've got a Windows machine, it's going to be possible to install Singularity on your Windows machine and run Singularity through a thin layer of virtualization. So it's going to, you know, from your user perspective, it's going to look just like Singularity is running directly on your machine. And in addition to that, we're working on transparent Mac support. In fact, we announced at the Singularity user group just a few weeks ago that this is actually something you can do right now. So if you go to Sylabs.io, there's a section there that has a download where you can install basically a compiled binary for Mac directly on your system, and then you can use Singularity directly on your Mac. Okay, so I told you earlier that I'm here representing Sylabs. So I wanted to talk a little bit about what Sylabs is and a little bit also about SingularityPRO while I'm here. So Singularity is obviously an open source product or an open source project. And, you know, it's great because we get lots of contributions from people all over. And it's also cutting edge. But the trouble, as many of you probably know, is if you use something that's cutting edge, sometimes you bleed, right? So that's where Sylabs and SingularityPRO comes in. So Sylabs is the company which is maintaining and fostering the open source community and also maintaining the open source version of Singularity. But we're also offering a stable, secure, production-ready variant of Singularity called SingularityPRO. Now, first, just to begin with, Sylabs is fully committed to open source. So when I say that, what I mean by that is every single thing that engineers at Sylabs develop for Singularity will always be rolled back into the open source version of Singularity. There will never be anything that we hold back only for SingularityPRO. You can think of SingularityPRO as being to Singularity essentially what Red Hat is to Fedora. So SingularityPRO we commit to long-term support for several different releases. So whereas in the open source version of Singularity, really technically only the latest version of Singularity is supported. With SingularityPRO, we're actually also backporting bug fixes that appear, in a later version of Singularity to earlier versions of Singularity, and we curate that content so that there's long-term support for multiple releases. So that ensures additional stability. Another thing that we do is new features that go out in new versions of the open source version of Singularity. Those are left for the community to play with and test for a while and make sure that they're stable. And then once we're so this once again goes right back to that Fedora versus Red Hat comparison. So once those features have been out for a while, we have a high degree of confidence that those features are stable. That's when we backport those features to versions of SingularityPRO. So another thing that you get with SingularityPRO is an additional level of security. And so let me talk about what that means. I've already said that everything that Sylabs creates, everything that Sylabs develops, is going to go into the open source version of Singularity. If you've been around the Singularity community for a while, if you've administered, especially if you're an admin, then you'll know that, this is container technology, and sometimes there are security vulnerabilities. So Singularity developers are constantly looking for vulnerabilities and watching for them, and we go through and create CVEs when we discover them. We go through we have an entire protocol together, which is a professional protocol, just like any other software, for how we handle security vulnerabilities. Well, if you're running the open source version of Singularity, what happens is, on the same day, immediately, we make the CVE public at the same time that we make the patches public that you can apply to the open source version of Singularity, and you can patch it. There's really no other way for us to do it. And so, unfortunately, what ends up happening then is that kicks off a race between any administrators that are using Singularity and any potential black hats which would like to exploit your system. And so hopefully your admins are quicker than anybody who happens to be, have access to your system with malicious intent. The way that this works if you have SingularityPRO is you periodically get updates anyway. We periodically send you, hey, you need to do a yum update because there's a newer version of Singularity, so go ahead and run that. Some of those updates will include security updates. We don't tell Pro subscribers which of those updates are security updates, because then, a user with malicious intent could just, pay the money, subscribe to Pro, and then get fast-track access to, understanding whenever there's a security update. But some of those updates will include security patches. We then wait a reasonable amount of time, assuming that the Pro subscribers have updated, and then we release the CVE from embargo, and we put the patches out in the open source. And by the time that occurs, the Pro subscribers are already patched. They don't have to participate in that race that occurs between the admins and any user that potentially has malicious intent. SingularityPRO also gives priority support for ticket tracking. So right now, if you're an open source if you're an open source user, then you've got GitHub issues, or you've got the Singularity Slack channel, and those are places that you can go to ask for support. And The community is pretty good. The community is pretty good at providing answers to those kinds of questions, but there's really no guarantee if you have like a time-sensitive question that needs to be answered. There's really no guarantee about when that'll be answered. So of course, with SingularityPRO, you get support with guaranteed escalation times and guaranteed resolution times and things of that nature. And then on top of SingularityPRO, we also offer things like professional services. So say you've got specific features that you'd like to have included in Singularity, you want some engineering work to be done, we could enter into an agreement to do that. Or if you want to host the Singularity container services on-prem, that's something that we're actively working on right now, and that's something that's going to become available in the future above and beyond a SingularityPRO subscription. Okay, so I've told you a little bit about just, what Singularity is, how it differentiates itself in the Linux container ecosystem, what's new in SingularityPRO and with Singularity 3.0 and Singularity 3.1 and what our roadmap looks like. And I've also told you a little bit about the company, Sylabs, and SingularityPRO. So that's pretty much it with that. Hopefully I've got some time to answer questions if there are any. Thanks very much for letting me come and talk to you.